In lesson 2.5, we want to model word problems, and we want to model them with algebraic equations. In the next few examples that I'm going to go through in this video, I'm going to show you how to take the information given to you in a question, come up with variables, use those variables to set up an equation, and then solve the equation for the given or requested information. Remember that every time you choose a variable, you need to provide a let statement to let the reader know or your teacher know what variable or what letter you have chosen to represent the situation in the word problem. In our first question, we are told that Brian operates a variety store with his sons, Simon and Robert. We know that Robert makes twice as much as Simon, who only works part-time. Brian makes $200 per week more than Robert, and the total weekly payroll is $1,450. We're asked to determine the amount that Brian, Robert, and Simon are paid for the week. So the first thing that we want to do is just come up with some equations that represent each person, or at least each of these pieces of information that were given to us in the question. So we are told that Robert makes twice as much as Simon. So I'm going to go ahead and write that out. So Robert, he makes twice as much as Simon. So that's the same thing as saying 2 times Simon. We're then told that Brian, he makes $200 a week more than Robert. So that's the same thing as saying 200 plus Robert. 200 more implies you're going to be adding on top of. So 200 plus Robert. And the total weekly payroll is $1,450. That means the total amongst all three of these men should add up to $1,450. So we know that our total is equal to $1,450. Okay, so we obviously know we can't use everyone's full name. We need to pick some letters to represent each of these people. So I'm going to go ahead and write some let statements to pick different letters to represent all of these different variables. So here are my 4 let statements. I had to use 4 different letters to represent 4 different things. So I said let the letter S represent Simon, let the letter R represent Robert, let the letter B represent Brian, and let the letter capital T represent total payroll. So what we're going to do is we're going to take these assigned letters and we're going to build an equation. So what we know is that the total payroll has to be Brian plus Robert plus Simon. So all 3 men have to be added together. So I'm going to go ahead and write that out. So I know that total is equal to S plus R plus B, Simon plus Robert plus Brian. So now we do know some information about each of these men, and we know information about the total. So we're going to plug all of that into the appropriate spots. So in the place of the letter T, I know the total. So the total I'm going to put in as 1,450. I don't really know anything about Simon. They don't tell us anything. So we're just going to keep this as the letter S. Got a plus sign. Now, we do know some information about Robert. We know that Robert is 2 times or twice the amount of Simon. So we're going to replace the letter R with a 2S. Okay, because remember we did say that Robert makes twice as much as Simon, or 2 times Simon. So we are using the letter S for Simon, so we can write 2S. Now in terms of Brian, we know that Brian gets 200 plus whatever Robert gets. So he gets 200 more on top of whatever Robert already makes. Now, when we look at our equation that we've built so far, we have the variable S showing up, and we also have the variable R. Remember that you can only solve an equation for one variable at a time. So I can't have S's and R's all at once because I can't solve for 2 different letters. So we do need to do something about this letter R, which R represents Robert. And we do know some information about Robert that we could use to replace this letter R. We know that Robert makes 2 times the amount of Simon. So rather than putting this letter R here, I'm going to erase it, and I'm going to replace it with another 2S. Okay, because we do know that Robert makes 2 times the amount of Simon. So now when I look at my equation, the only variable I see is the letter S. So I'm going to simplify this down a little bit before we actually start to solve. And I'm going to look for like terms, and I'm going to put them together. So I do see that I have some terms with S's that I can group together. So my next line is going to say 1450 is equal to, so let's add together the S terms. We've got 1S plus 2S plus another 2S. So that would be a total of 5S. And then that 200 is still hanging out. We can recopy it. All right, so now to solve, we need to make sure that we've collected variable terms and constant terms. So this 200 needs to move over to the other side. So that's going to leave us with 1450 minus 200, which is equal to 5S. So 1450 minus 200, that is 1250. To get S by itself, we're going to have to divide both sides out by 5. And so that is going to leave us with 1,250 divided by 5, which is 250. So this is our answer for S. Now remember, S represents Simon. So we know that Simon at the end of the week is going to get $250. So that's great, but now we still have to go back and figure out how much Robert would make and how much Brian would make. All right, so Robert, we know, makes 2 times the amount of Simon. So we do know now how much Simon gets. Simon gets 250. So I'm going to replace S with 250. And I can actually calculate how much Robert will get. So Robert gets 2 times 250, which is 500. So Robert is going to get $500 at the end of the week. And we can also now calculate Brian. We know that Brian gets 200 more than Robert, but now we know that Robert gets 500. So let's fill that in the place of R. So instead of R, we're going to put in 500. And so Brian would then get $700 at the end of the week. Now, how could you check and see if your answer is correct? Well, we do know that the total payroll, or the total amount of money at the end of the week, should be $1,450. And so if you took each man's weekly earnings, so 250 plus 500 plus 700, that should add up to a total of $1,450. In our next question, Justin works at a ballpark selling peanuts. He's paid $6 per hour plus 50 cents commission for every bag of peanuts he sells. So what we know about Justin is how much he makes every hour, and we know how much money he makes or earns for every bag of peanuts he sells. What we don't know is how long does he typically work in a day, and we also don't know how many bags of peanuts he can typically sell in a day. That's going to change depending on the day or the situation. So we are going to need variables to represent the number of hours worked and the number of bags of peanuts. The other thing that we don't know are Justin's total earnings, right? Because it's going to vary or change depending on how long he works in a day. And on top of that, it depends on how much or how many bags of peanuts he can sell. Some days he's not going to sell very many. Some days he might sell a lot. So for this question, we also need to make sure that we pick a variable to represent earnings. So here are the variables that I chose. I said let E represent earnings, let H represent the number of hours worked, and let P represent the number of bags of peanuts. So now that I've picked my variables, I can go ahead and build my equation using the information that was given. So we know that in order for Justin to get some earnings, he gets $6 an hour. So that's 6 times H, or 6H, plus 50 cents. Now 50 cents is a money value, so we got to make sure that we write it as a money value. So 50 cents is actually 0.50. So he gets 50 cents for every bag of peanuts. So that's going to be 0.50 P. So here's my equation. Now that I have the equation, I can go ahead and calculate answers for part A and part B. So in question A, we're asked to find Justin's earnings if he sells 42 bags of peanuts during a 4-hour shift. So we are told that he can sell 42 bags of peanuts. So that means in the place of letter P, I can put in the number 42. And we're also told he works a 4-hour shift. So that means in the place of the letter H, I can put in a 4. So on the screen, I've done that. I've put in a 4 for the 4 hours in the place of H, and I've put in 42 in place of P. So now we're going to go ahead and calculate this. So 6 times 4 is 24. 0.50 times 42 is 21. And if I add those numbers together, I'm going to get 45. Don't forget that you need to put a therefore or a concluding statement or sentence at the end. So I'm going to conclude, therefore, Justin would earn $45. Remember, earnings are a money amount measured in dollars, so you should be putting in the symbol for $ as your units. For question B, we are asked how many bags of peanuts must he sell to earn $100 in 7 hours? So this time they are telling us that he actually can earn $100. So 100 can go into my equation in the place of the letter E. It is an earnings value. And again, they tell us the hours that Justin works, and this time he works 7 hours. So in the place of the letter H in my equation, I'm going to put in a 7. So I've gone ahead and done that. So in the place of the letter E, you can see that I've put in 100 for the $100 that he earns. And in the place of H, I've put in 7 for the 7 hours that he works that day. So the only thing we don't know, or what we have to solve for, is P. We need to figure out if he works for 7 hours and earns $100, how many bags of peanuts does he have to sell to make that happen? So we can simplify this a little bit. We know that 6 times 7 is 42. So now this is going to work out like a regular 2-step equation. So you need to group or collect your like terms. So that means the 42 needs to move over to the left-hand side to be with the other plain number. So if I move that 42 over, it's going to switch signs and become a minus 42 or negative 42. 100 minus 42 is 58. And then to solve for P and get P by itself, we're going to have to divide both sides by 0.50. So that is going to give us an answer of 116. Don't forget to put in a concluding statement so we can say, therefore, Justin must sell 116 bags of peanuts. In question number 3, the length of a rectangle is 7 meters more than its width. The perimeter of the rectangle is 60 meters. What are the dimensions? So if you haven't heard of the word dimensions before, or you're not sure what that means, dimensions just means they want you to find the side lengths, meaning the length and the width of the shape. So we need to solve for the length and the width for this rectangle. Now they've given us a lot of information, but again, before we start, we just want to pick some letters or some variables to represent the things that we don't know. So I've gone ahead and picked 3 variables. I've chosen a lowercase l to represent length, lowercase w to represent width, and a capital P to represent the perimeter. So let's go ahead and go back to the question now and read what information was given to us. So for this particular rectangle, the length is 7 meters more than the width. So if we were to take that information and translate it directly from English to math, we could say the length is 7 meters more than the width. So that is L equals 7 plus W. So that's a little bit of information that we were given. The other thing that we were told is that the perimeter of the rectangle is 60, which means if we added up all of the sides of our rectangle, we would get 60 meters. So you may not know this, but there actually is a formula to find the perimeter of a rectangle, and that is P is equal to 2 times the length plus 2 times the width. So if we think of a rectangle, remember that the top and the bottom are the same. So we could call that the length, maybe. And then the left and right sides are the same. And that could be represented by the width. So we have 2 L's plus 2 widths. Okay, so the L's go together, so that's the 2L. And the W's can go together, that's the 2W. And to find the perimeter, we need to add all of it together. So that's where this P equals 2L plus 2W comes from. But what do we know about the length? We know that the length is 7 plus W. So what I can actually do is take this little piece of information and stick it into the place of L. So that's going to give me P equals 2 times 7 plus W plus 2W. Now remember, we can't solve for 2 letters at a time. So by replacing L with what we know, we actually end up with just the W's. Now you might say to yourself, well, you also have this letter P, but I'm going to erase that because we do know what the perimeter is. The perimeter of this rectangle is 60. So in order to solve for the variable W, the first thing we're going to have to do is distribute this 2 into the bracket. So that is going to leave us with 60 equals 14 plus 2W plus 2W. All right, so now we want to go ahead and collect like terms. So in order to do that, I'm going to take this 14, and move it over to the left-hand side. By moving the 14 over, it's going to become a minus 14. The 2 W's are just going to stay where they are. Okay, and now we're actually going to do the math. So we've got 60 minus 14, which is 46. And 2W plus 2W is 4W. Okay, to solve or isolate for W, we need to divide both sides by 4. So 46 divided by 4, that's going to give me 11.5. So the width of this rectangle is 11.5 meters. So great, we got the width, but remember you also need to find the length. Now, in order to do that, remember we already know that the length is equal to 7 plus W. And we just figured out what W is. W is 11.5. So I'm going to replace the letter W with the number that we just calculated. And if I add those two numbers together, 7 plus 11.5 is 18.5. To finish off, we're going to write in a therefore statement. So we can say, therefore, the dimensions of the rectangle are 11.5 meters by 18.5 meters. So one side of the rectangle is 11.5 meters. Another side would be 18.5 meters. Another common word problem involves consecutive numbers or consecutive integers. In question number 4, we are told that 3 consecutive integers have a sum of 75. what are the three integers? So we don't know what these numbers are, what these integers are, so we are going to have to define some let statements to represent each of the three numbers. So I'm going to go ahead and start by saying let x represent the first integer. So the very first mystery number, whatever it is, let's represent that with x. If I want the next number in order, in consecutive order, that would be represented by x plus 1. So whatever that original number was, if I want to get to the next number in numerical order, I would just add a 1 to it. So let x plus 1 represent the second integer. And if I want the third consecutive integer, I'm going to say let x plus 2 represent the third integer. So there are my three consecutive integers and an algebraic term or expression for each one. Now, to take the sum of those integers means that you need to add them together. So let's take those expressions we just came up with and add them together. So that means x plus 1 plus x plus 2, all of that together has to equal 75. So this is a really simple, straightforward equation to solve. What I'm going to do first is I'm going to go ahead and collect all my like terms that show up on this left-hand side. So I do see that I have some x's that I can put together, and I have some plain numbers that I can put together. So let's start with the x's. I have 1x plus another x plus another x. So that is a total of 3x. In terms of the plain numbers, I've got a 1 plus 2. So that would give me a positive 3. That is still equal to 75. And now in order to solve, we're going to take this positive 3 and bring it over. So that's going to leave us with 3x equals 75 take away 3. I do know that 75 take away 3 is 72. And I'm going to finish off by dividing both sides by 3. Okay, so we're going to perform the division. 72 divided by 3, that gives me 24. So my very first integer, which was represented by x, if we go back and look at our let statement, okay, our first number is 24. So if I want to get the second integer or the second number, I just have to take my x value and add 1 to it. So on the side here, I'm just going to show my work. Okay, so the second integer is x plus 1. So 24 plus 1 is 25. And my third integer was represented by x plus 2. So I know x is 24. So x plus 2 would be 26. Okay, so my three consecutive numbers or integers that we were supposed to figure out or asked to figure out, our answers are 24, 25, and 26. So you can very clearly see that they are consecutive. They go in order, 24, 25, 26. So here's another version of an integer question. This time, three consecutive even integers have a sum of 102. What are the three integers? So if we're asked about even integers, remember even numbers are numbers that end in multiples or factors of 2, right? So if we're counting even numbers, that would be things like 2, 4, 6, 8, 10, and so on. Okay, so the setup is going to be very much the same as question number 4, but the way that we come up with those expressions for the consecutive numbers, it's going to change a little bit. So I'm going to go ahead and write out my let statements, and then we'll talk about how we came up with them. So we've got to start somewhere. So we're going to say let x represent our first integer, so our first missing mystery number. If I want the next consecutive even integer, normally we would add 1 to get the next number, but because we were focusing this time on even numbers, I'm instead going to add 2. And x plus 2 is going to represent the second integer. To get the third consecutive even integer, instead of adding 2 like we normally would, we're actually going to up it to 4. So if we were to ask, or if we were asked to find, let's say, the fourth integer, well, then the next one, the next consecutive even integer would be represented by x plus 6. If you wanted the next one, it would be x plus 8. If you wanted the next one, it would be x plus 10. So you can probably hopefully see the pattern. If you're trying to count consecutive even integers, you need to skip count by 2s or by even numbers. This time we're told that our integers have a sum of 102. So if we take our expressions and add them together, this time it should equal 102. So I'm going to go ahead and collect like terms. So I'm going to add all my x's together. That's going to give me 3x. And I'm going to add my plain numbers together, 2 plus 4. That's going to give me 6, which is all equal to 102. Okay, we're going to move this plain number over. That's going to leave us with 3x equals 102 minus 6. 102 minus 6, that's going to give us 96. And our final step is to divide both sides by 3. So 96 divided by 3 is 32. So if x is equal to 32, that means our first missing integer is 32. So to get the second integer, we need to take x and add 2. So 32 plus 2, that's going to give me 34. And to get the third integer, okay, we need to take x and add 4 to that. So it's going to be 32 plus 4, which is 36. So our 3 consecutive even integers would be 32, 34, and 36. One of the most common types of word problem questions that involves algebra are questions where you need to determine someone's age. In question number 6, we are told that Catherine is 2 years older than her sister Christine. The sum of their ages is 16. How old is each girl? So to begin with, remember that we always need to pick some letters or variables to represent the information that's given to us in the question. So in this particular question, we have 2 people that we are talking about, a person named Catherine and a person named Christine. Now, both of their names start with the letter C. So you can't use the letter C to represent both of these girls. So we could say, let C represent Catherine. But once we use the letter C for Catherine, that means we need to pick a different letter for Christine. Now, a common mistake that students make is they think, well, let me use then CH to represent Christine. However, the problem with this is that you cannot use 2 letters at a time. Remember, 1 letter or 1 variable has to be assigned to each item or each person. You can't pick 2 letters because this would look like these 2 variables side by side were being multiplied together. It would look like C times H, and C would represent one thing and H would represent something else. So avoid using double letters. So I'm going to erase this. So maybe instead of using a C for Christine, let's say let K represent Christine. Okay, so So let's write out some information that we know. So we're told that Catherine is 2 years older than Christine. So let's translate that. So Catherine is 2 years older than Christine. Okay, so C is equal to 2 plus K. Now, we're also told that the sum of the sisters' ages is 16. So if we add Catherine plus Christine, that should give us 16. So remember, you can't solve an equation with 2 different letters. You can only solve 1 letter at a time. So like we did in a previous problem, we do know information about Catherine, this 2 plus K, that we could take and stick into the place of C. So if I replace that, it's going to become 2 plus K equals 16. So now we're only working with the letter K, and so we're going to start by solving this equation that we just created for K. All right, so you could just take off these brackets to begin with, and then what you could do is either collect like terms or simplify a little bit first, or you could just go ahead and start moving things around. So I'm going to actually do some moving around, and I'm going to take this 2 and bring it over to the right-hand side. So that's going to leave me with K plus K equals 16, take away 2. If I now collect some like terms and simplify, K plus K is 2K. And 16 minus 2 is 14. So our final step to solve for K would be to divide both sides by 2. And so K would be equal to 7. So now that I know K, I can go back and solve for C. So remember that we know C is equal to 2 plus K. But we now know that K is equal to 7, so we can go ahead and stick that in. 2 plus 7 is 9. To finish off, we will write out a concluding statement. And we can say, therefore, Catherine is 9 years old and Christine is 7 years old. And we know that our answer is correct because we know that if we take these 2 girls and take their ages and add them together, it should add up to 16. And 9 plus 7 is 16.